And welcome to our final chapter this semester, Chapter 11. So, in Chapter 11, we are going to be talking about a lot of the stuff that we covered and some of the stuff that you will be covering in the near future, maybe in 205 and even beyond that. A little bit of security, a little bit of how to back up and take care of your devices, um, even designing a LAN. So we'll be talking a little bit of everything that we'll be doing next semester and the following semester and after that. Okay, so let's get right into the chapter. Let's talk about how to create and grow a network from scratch. So let's say you have a very small network, which typically a LAN that everything connects to a switch, and the switch should be connected to a router that's going to take you to the outside world. So we're not talking about a lot of users here. We're talking about maybe in teens, uh, but you may have a much bigger network, for a corporate environment. But when you are going out to purchase intermediate devices such as switches or routers, the first thing you are going to consider, of course, how much it's going to cost you. You know, your client has to decide how much money they are willing to spend on these devices. How many ports on the switch do you need? The density? That all depends on how many devices are going to be connected. Okay. And what's the speed of these ports? That's going to determine, also that's going to tell, that's, that's going, it all depends on what kind of applications and how much, and do you need real-time communications such as voice over IP or real-time videos? Um, So, and again, but if you have the money for it, go for full duplex fiber optic Ethernet if you can. Do you want expandable or modular? Can you expand these ports if you wanted to? You can do daisy chained. I think we talked about that earlier. And does these devices allow you to manage and control these devices? How easy are they to manage them, secure them? Right? So all of these are different considerations that you have to be looking at when you are purchasing these devices. Okay, so the IP addressing, you have to sit down like we've been doing with the subnetting, set out each network, each LAN. If you're doing multiple LANs, each LAN should have its own IP subnet address. And so this way you can write the logical topology, the subnet on a piece of paper, all the LANs and how the physical topology, how all the devices are connected, and write down each subnet for each LAN. So this way, when you are as an administrator, you want to be able to track these devices so you can troubleshoot them very easily. And remember, I told you that earlier, I think I did, that your first day on the job is to be able to create a logical and a physical topology of the network that you are responsible for. All right, so this makes it a lot easier to maintain, troubleshoot, expand, and so on later on. All right, we want to also make sure that your network has redundancy. Remember, your number one job as a system administrator or a network engineer is that users always have connections to their resources. They should have access to their resources regardless. So one way to do that is to have redundancies in links, for example. And as in this case, as you can see, if this is called a mesh topology, actually it's semi-mesh, it's not full mesh. And so this way, if one link breaks, so for example, you have multiple ways to get to this LAN to this LAN. So there are multiple ways to get to here, the server farm, they call it, right? So you can go here, you can go this way, you can go that way. There are multiple ways to get to any server. So this way, if any link breaks, there's always another way to get there. All right, on your router, you want to be able to set priority for traffic. So, for example, if you know that there going to be a voice over IP packet coming in, that's the packet that should be routed out first before any of the others. Okay, that means this router has to have QoS, quality of service. That's what allows you to set priorities to traffic. So, question number one: what does QoS means quality of service. And what does it do? It allows a router or a switch to set priority to traffic. There you go. All right, so you will have network aware applications. That's the software programs that are used to communicate over the network, and the application protocols that allows you to transfer data. All right. Here are some network protocols that we've discussed earlier. So this is something that you will be working on after you set up the infrastructure. Actually, Cisco really concentrates at the bottom three layers of the OSI model with routing, switching, and the devices that connects to the switches. All of these, you're setting up the infrastructure, the traffic flow between these devices in a secured, quickest way, fast, most secure, easy to expand. So all you have to do at the application layer is set up all of these different network protocols. For example, you may have to set up a DNS server, a telnet server, an email server, a DHCP server, but all of these different servers, application servers, we still have to go through the switches and the routers to get to the destination to get to their clients as quickly as possible. So we really do the hardware, the infrastructure, the actual roads, and the quickest way for anybody wants to access any of these servers to get them as quickly as possible. So for example, Microsoft Linux servers can do all of these for you, right? All right. So you also have to have some real-time applications. You want to be able to acquire data immediately on and find out what's going on. For example, you want to evaluate the traffic that is happening on your computer so you can isolate problems. So, you need applications that do the infrastructure, check out the infrastructure and how everything is connected. If there's any problems for troubleshooting purposes, you may want voice over IP. That's implemented in companies that already have the old telephones. For in the early 2000s, that was a big thing. Everybody wanted to leave the old landline telephone, which cost a lot of money, and convert that into voice over IP. Now a lot of the companies immediately go for the IP telephony, where you buy the telephone and it can do everything for you, just connected to the internet. You don't need to be connected. You don't have to have an old landline signals. That's pretty much dying out. Real-time video protocols, you use RTP and RSTP. This is the one that allows you to transfers video in real time. That's mostly for video over TV, or let's say doctors in different locations want to be able to see the patients, I don't know, x-rays or whatever in real time, or an operations, for example. So you may have to set up some video between them, or different companies want to be able to do video conferencing and things like that. For a small company, scaling a small company, meaning if you started out with a small land, you want it to be you can easily expand it. You want it to be, in other words, scalable. So make sure everything is documented, the physical and the logical topology. Remember that? The physical topology is the physical layout of the devices, how they are connected. The logical topology is the IP addressing of each device, the subnet, and where they belong. Device inventory, you should do that at least once a year of everything that you have, devices, right down to how many mice or keyboards you have. All right, and where they are located. So this way you can create a budget. How much is it going to cost you for redundancy devices, or what's important for you for security, for any of that. You want to also be able to have traffic analysis, realize where all the traffic is coming from, where the bottlenecking is, so you can ease traffic. So in case you need to expand, you want to stay away from bottlenecking into the router. You may have to upgrade your switches, or maybe even, hopefully you don't have to do upgrading the wiring in the building. Or do you want to go wireless? So having an idea, if everything is documented and you know how everything is connected, it'll be easy to expand. You just don't want to keep adding devices not knowing um, how everything is connected. By the way, we will design when we talk about LANs next semester, the switching and the routing. We have a way of designing the LAN so that it is easy to expand and it will be very secured and it's the quickest way to access any of the resources needed by anyone in any LAN. So we'll talk about designing a LAN later on. Here's a typical network analysis software that goes out and finds out the traffic, which LAN and which device is creating the most traffic at one time. You create a baseline. So this way you can always have something you can reference to in case there is traffic, maybe attacks. You have an idea on how what's quote unquote normal traffic in the time of the day. It could be weekly, monthly, yearly, right? Uh, you want to be able to access software, for example, applications, what the processes are doing. That gives you a snapshot of uh, the applications that are running on your device. You guys are probably familiar with this with the task manager. You can actually, if your computer is running very, very slow and your CPU and your hard drive is running like crazy, just do the control delete, go into the task manager and find out which one of those services or processes is making the CPU go up to 100%, and you can actually stop it in some cases. All right, so now let's talk about security, securing the LAN. The most important thing when you are talking about security is not only information theft, we're talking about hard drive crashing, not being able to access some of your applications, viruses getting into your PC, not be, again, denial of service, identity theft, somebody grabbing your social security number and your name, right? And using that information to do whatever they want. And you're going to be responsible for it. That's the part. There's always over $2.5 billion a year are lost caused by identity theft. All they have to do is get your name, your social security number, your date of birth, and they're good to go. Never ever give your social security to anyone. No one needs it except the IRS, right? So if you go to a doctor, they usually ask for that. I never give them that. There's no need. What do they need your social security for? I'll tell you why they need it. They think because you're not going to pay and they want to track you down. So don't give that to even the doctors. When you go to a doctor's office, give them your license, and if they don't, usually they never bother me. I never give it out. I give them my license, and if they don't like it, that's too bad. Reason for them to take your social security number because you don't know how they're gonna secure it and maintain it. That person that takes your name and social security number and all the good, and they have your address and everything. Anybody can get it. So be very careful when you're doing that. All right, so there are four classes of physical threats to your devices. Hardware threats, meaning the physical damage to the servers, routers, and probably that's, the most important thing. No matter how secure your network is, if intruders are able to get physical access to your devices, all your security is really useless because they can take your router and switches and the window and servers. And it doesn't matter how nicely and tight you secured it with passwords and encryption and whatever, right? So you got to make sure that your servers, your routers, your switches, everything in a place where no one has physical access to them. All right? And you don't want them to be damaged, of course. And the damage could be caused by environmental threats, electrical threats, or maintenance threats. Temperature is too high. The server starts to reboot themselves. So you got to make sure that there is enough ventilations, HVAC. All right. Humidity cannot be too high either, or too dry, because if it's too dry, you can accumulate a lot of static charges, and that's not good. Electrical threat, make sure that you or generators, just in case, right? Or voltage spikes. You're gonna have those suppressors or circuit breakers. Okay, that all has to be set up. Maintenance threat. You do electrostatic discharge. The number one, I remember many years ago, the number one problem Dell had with their maintenance, 90% of the problems of PCs were users being able to open up the boxes and start trying to fix the PC components. And because of poor electrostatic discharge, they really screwed up the whole motherboard. So what they started doing, they put a little tape on behind the box, and they said if that tape is broken, you try to get into the box, you void the warranty, and they solved that problem that way. All right, vulnerability, weaknesses. There's plenty of vulnerabilities. When you TCP/IP protocols, all the protocols that we talked about, HTTP, FTP, Telnet, all of these protocols always transfer data in clear text from the early 1970s. They were not worried about security. Operating systems, as you probably know, there's always being patches that keeps coming up to close loopholes that the operating systems from Linux to Mac OS to of course Windows, they always have these little security loopholes that they need to close later on. So you got to keep an eye on that, and you want to make sure you always download these patches and install them immediately. Those service packs are very important, especially for you know, uh, the security ones. Okay, so there are some technical equipment weaknesses. For example, for routers, firewalls, switches, the defaults that they have, the default username, default passwords, some commands that you can use to access information from other devices. So all of that is in there. All right, let's talk about the viruses, Trojan horses, and worms. Viruses is any program that is attached to another program, and while you're downloading it, and once it gets to your hard drive, it just can cause havoc. You can go in and start erasing files and many different things. So you do not want to get a virus on your machine because it'll be a headache to get rid of. A worm, on the other hand, is really nothing but a virus, but the difference is what it does is propagates itself to other machines in a network. So if you are connected in a network, you got a whole bunch of machines that are going to be infected. And that's really a major headache for an administrator. Trojan horses. A Trojan horse is you know an app, a file that is saved on it's downloaded on your computer and you don't know what that application is. You think it's a program that you like to use, but what it does, it's really an attack tool. It can sit there, gather information, and you don't even know that this application is, you think it's legitimate file, but it's really a file that either doing harm to your PC or um, or transferring information to an attacker outside your land. So you got to be very careful. All right, question number 2. Describe what a virus, a Trojan horse, and a worm is. So there you go. Write these down right here. All right, now reconnaissance attacks. Reconnaissance attacks meaning going out and finding out information, looking around. All right, so you can do internet queries, for example. Oops, let me just go back. Sorry about that. Typing who are you on the internet, figuring out if you are connected or not. You can do ping sweep, ping everybody in the LAN and see who responds to you, so you know who is connected. That's why a lot of firewalls do not allow anybody to ping them. Don't respond to any ping commands. Port scanners allow you to go out and find out which application on your machine is open, so you can send data to your machine, because your machine is firewalls usually blocks all ports that are not being used. Packet sniffers is like it could be a hardware or a software. that scans all the data that's being transferred on the wire and convert it from bits, ones and zeros, into clear text. So that's the reason we need to encrypt the data to fight against those packet sniffers. Wireshark, by the way, is a type of packet sniffer, protocol analyzer. All right. Access attack, being able, they're trying to break into your network. So they may use what's called brute, brute force attack. Somebody's constantly trying to guess your password. And how do you take care of that? Well, by giving by giving the user that's trying to break in 3 tries and then break it out. Because what they do is sometimes brute force is they run a program that keeps guessing what the password is. And after a little while, given enough time, if your password is not strong enough, they'll guess it. They may have Trojan horses programs, programs that you downloaded and you type, and they gather all that information and they can get your password that way from a Trojan horse, or keyloggers, keyboard loggers, for example. Packet sniffers, somebody's watching the data that's flowing in the network and can see your password. All right. So therefore, you got to make sure your password is strong. We'll talk about what is strong means in a second. Port redirection is being able to compromise a host, a host that passed traffic through a firewall and would otherwise be dropped. So, for example, A is able to go through the security to get into the network. So what I do is I compromise host A. I'll use him and then go through him to get through the firewall. So if I can attack this guy outside the LAN, I can, you know, make myself look like him, spoof him, and go. I'll be able to go through the firewall. Denial of service attack is somebody on the outside is constantly sending you requests, so they can actually eat up your disk space. Your bandwidth is going to be very, very small. Um, I can do that with lots of pings so that the server cannot constantly is responding to these pings and it's not able to communicate with anyone else. All right, so all of that. Um, Here are some examples such as UDP bombs and fraggles are different types of packet storms. You can actually Google these and have them. All right, but there is a way by placing an IPS and intervention, intrusion prevention systems that can detect the signature, quote unquote. Signature means the pattern of these attack and stop it before they get it actually into the server itself inside the LANs. So IPSs will be able to detect attacks such as these DOS and stop them from happening. Okay, so now you are responsible to make sure that you are backing up, upgrading, updating, and patching your operating system. This is another word for hardening your device. Hardening your device meaning you have a backup that you know how to restore, upgraded to upgraded your operating system because your old operating system may be vulnerable to the new attacks. Update all the information. Updating and downloading and installing the patches is very, very important, especially in operating systems. Okay, because they are vulnerable to these attacks, and um, companies such as Microsoft keeps an eye on all the different problems and the security loopholes in their operating system. And every once in a while, they send out a patch, and your computer has to be, I think it's by default, they are set up to automatically download and install these patches. So you got to make sure that that happens. You want to be able to do the AAA on everything on that happens on your computer, all the events, authentication, authorization, and accounting. So anybody that goes into your network has to be authenticated, validated. Make sure that they have a username and a password. If they come in physically through the building, that they have a badge or a password, you know, the key door password, for example. All right. Then authorization. Once they are validated, once they are authenticated, then you allow them to go in and perform whatever they need to perform. So if they go and access the certain applications, you authorize them to do that. That's authorization. If they are not authorized to use um, a certain application, such as AutoCAD, that means they're not authorized. All right. Then you keep an account. You figure out what they did at the end of the day, right? So that's what the AAA is. AAA is like using your credit card. You swap your credit card, you type in your key or your password, right? And then that password goes out and you get authenticated. Then the credit card company authorizes you for $10,000 usage. So you can use all of that. Then at the end of the month, they'll give you a record of everything that you did. That's accounting. So this way you can see if you did really purchase all of these different items. That's what the AAA is all about. Firewalls. Firewalls are like I told you earlier, they're like security guards in front of the building. They check every packet that comes in and then they inspect the list to make sure that if you are on the list and you're supposed to be denied, then you are not allowed access. If you are permitted, then you're allowed permission. So that's what a firewall is. It cannot detect. Sometimes it cannot detect attacks. So somebody spoof you, like we talked about earlier, for redirection, that could happen too. So that's why we need IPSs in there too. Firewalls are not good enough. Next semester, we're going to be able to use the router as a firewall, and we'll see an example on how to set it up that way. All right, securing your end devices from your phones to your PCs to your TVs, your laptops, you name it. You got to be able to, especially if these are not home, if you're not at home and if this is in a corporate environment, you want to make sure that users do not just download anything on their computers and install anything that they want, and they have to be audited every 3 or 4 months. By the way, if you tell the users that they are going to be audited every 3 or 6 months, they usually don't do anything to their devices, don't install applications, don't go places where they're not supposed to. That's the easiest way to take care of it. Just tell them they're going to be audited, even if you don't do it. Just telling them that um, prevents a lot of problems. Okay. So let's talk about securing these devices. Okay. Default username and password should be changed immediately. So if you have something like that, get rid of it. You should never ever leave the default username. They do that sometimes in school to give freshmen the ability to log into the network. They use a guest password for like the first couple of weeks, and I've known many universities they leave it on forever, and that's very very dangerous. Okay. Access to accessing to system resources should never be accessed by users. Only the administrator should be able to access system resources, like routers or switches or anything like that, right? Anything that's unnecessary services or devices or applications should be turned. Anything that you're not using that comes by default, turn it off. Don't use it. Uninstall any applications that you're not using, right? And security patches, always update them immediately, as I said, when they become available. All right, let's talk about passwords. You want to have a very strong password. So, password, using a dictionary word or somebody's name, very bad. Even just a name with numbers, because they can easily be guessed. Strong password is when you use lowercase letters, numbers, where it's very difficult to guess what it is, and you want it to be long. So the rule is use uppercase, lowercase, numbers, and some symbols. Make sure your password is more than 8 characters, and then you'll be good to go. You can go to passwordmeter.com to test your password right now to see how strong it is, and they'll give you a number. Here, for example, on your router, you can remember we did this, encrypt all the passwords. So when somebody types um, show run all the password in the configuration file will be encrypted. That includes the console and the telnet password, right? On the router, you can set a minimum length of all the password. In this case, it's 8. So security password min length should be 8 characters. So you cannot create a password that is less than 8 characters in this case. Login block for 120 attempt, 120 seconds, attempts 3. So if anybody with a guesses the password wrong 3 times, they're going to be logged within 1 minute. If they try to guess the password within 1 minute, that's 60 seconds, lock them for 2 hours, lock them out. So they won't be able to get back into log. This is to really prevent against these brute forces. And you put that on the VTY line, right? VT, or you can set up the V, well, you can set up the VTY line, say exec timeout 10 seconds. In other words, if you leave and there is no activity on the telnetting for 10 seconds, the session will end. All right. Now, remember, telnetting, as I told you earlier, everything is transferred in clear text. And if you are far away from the device that you are accessing, somebody between you and that device may see everything. But if the data is encrypted using SSH, then there won't be that man in the middle will not be able to use any of that information because all he sees is gibberish, really. So here's how you can set up SSH. The data, as I said, the data will be encrypted between you and the remote device that you're trying to access. The first thing that you are going to do, create a domain name, create a key using this command, and give yourself a username and a password. Okay. Then you go to the telnet, line VTY04, say I want the username and the password to be authenticated locally on the server. And you say I want to transport input SSH, no telnetting. So you have to use an SSH software to get into the router. Once you get in there, when you click on a software on your PC trying to access this router, for example, using a PC, they're going to ask for a username and a password. You type Bob as the username, Cisco as the password, then data will be encrypted between back and forth. We'll be able to talk about these later on. But here's question number, I don't know, is it question 3 or 2? Whatever. What are the steps to set up and enable SSH? Right here. These are the 4 steps. Please write them down. Configure an IP domain name, generate a secret keys, verify or create the local database entry, and this is right here, username and password, and then enable the VTY inbound SSH session. That's down here. Okay. Basic network performance, all right, being able to use the ping commands, for example, for testing purposes. So if you go to your PC and you ping 127.0.0.1, that tests the local stack. Remember that? Just to make sure that your computer is able to communicate TCP/IP. Now, if you are on the router and you use the ping command and you see an exclamation mark, that means you got an echo reply. That means the person that you trying to connect to is there, and he responded back successfully. So an exclamation mark is a success. If you see a dot, that means your ping packet got lost, and we don't know exactly where it died. So when you get these dots, remember this is on the router. If you see a U, that means the router doesn't know where you're trying to go. Unreachable. I don't have information about where you want to go. That's why the U is there. If you can use an extended ping command, that means you can give more information, control about how big, for example, the datagram should be, how many times you want to ping this device, and so on. Excuse me. So using the extend ping command can give you more information about troubleshooting. I mean, I think there are some labs that allows you to do that. I don't think it's that important. But you do this again on your router. Uh, from your PC, we've done this from the command prompt. You can ping the device that you want, and if you get reply from that 1.50 that's how you see a success, right? Um, so in the terminal session, if you want to save the configuration file, you want to go and capture text, and then everything will be saved, and you can put that in a text file in Notepad. So in case something goes wrong with the router, you will always have the file saved somewhere else. What I usually do is I type show run, I I copy and paste it and put it into Notepad. And then if I want to bring it back, I copy paste it from Notepad, go to config T on the router and paste the host, and bingo, everything comes back. All right, the trace route command. When you want to trace route, you want to find out every hop your packet goes through until it gets to the destination. Remember we did that too previously? So you want to see exactly where your packet fails, if it does fail. Here are some show commands that allows you to help you troubleshoot um, your network. Show running config. You want to display the actual configuration file that's in the RAM that the CPU is interpreting right now, right? Because anytime you make changes, you know, the startup config that's in the NVRAM may be different than the running config, because once you turn your router, the startup is the running. But if you start making changes, the running will be different then, right? Show interfaces. It gives you all details about how the interfaces are configured. For example, if the encapsulations on each interface changes, the IP addresses, and there's a whole bunch of other information we will see. We will use that a lot. Show ARP to make sure that all the ARP cache has the IP addresses and the corresponding MAC addresses, right? Show IP route displays the routing table on the router, right? So if you're trying to reach somebody and you can't reach them, one of the first thing you do is you take, do I have, is it in the routing table or not? We'll talk about that next semester, how to make sure that all the routers know where everybody is located, and we can populate the routing table using static routing or dynamic routing, but that will be discussed later on. Show protocols if you want to find out what routing protocols that are running on your router. Routing protocols such as RIP, the Router Information Protocol, OSPF, or EIGRP. Show version. Version is you want to find out. There's a whole bunch of stuff that you can find about the show version command. And here they are. For example, what version of the operating system that you have, the bootstrap version that you got. Here is the name of the operating system. And you see, remember, I said that the first part of the name tells you for which router. This is for router 2500, for example, right? The CPU, RAM, and a whole bunch of other information that we will use. All right, so the show version gives you a lot of information about your router. All right, you could do that also, of course, on the switch itself too. Pretty much the same kind of information you get. Okay, you could type ipconfig. Remember the ipconfig command? The one with the /all gives you all the information, the IP addresses, the IPv6 address, the MAC address you get in there too with the OL. If you type display DNS like we did earlier in chapter 10, when you want to display the DNS, you want to figure out all the DNS and the corresponding IP addresses for those names in the DNS servers that you have accessed, all the cached DNS information. You can do ARP-A. I think we did that too a while back. Every time you go out and ask for a MAC address to be stamped on the frame that you are sending, that's where the word dynamic comes in. This is all in the cache, so you don't have to keep sending out ARP requests, right? Uh, the show CDP neighbors. Show CDP neighbors. I don't like this command because if you leave that command and you're not using it, Attackers may use this command to access information about all the devices that are directly connected to you. And look, it can give you the IP. Let's say you don't know the IP address of a router that you're trying to attack, which is directly connected to you. By typing show CDP neighbors detail, it gives it to you and it tells you what type of router it has, all the goodies, what interface it has, right? So this way you can dig up and say, aha, I know I got software that knows how to attack the 1841 router. I know the IP address and which serial port it connects to. So you get a lot of information. In fact, Cisco recommends that you do not use these if you really don't want to get any information. When we talk about the CCNA security course, show interface, show IP interface brief really gives you a quick snapshot of all the interfaces and how they are, if they are configured correctly or not. For example, you want to see fast Ethernet 00 and if 00 are connected, you see that they are both up, so that means they're up and running, right? Administratively shut down means they've been taught to shut down on that interface, okay? Here are some example of the ping command, and the exclamation mark means success. So this router 1 trying to reach 192.168.254.1, and it was successful, right? You can trace route. Another IP address tells you the 3 different hops, and they are all successful, but there is a failure right here. See that? That means it failed at the second try, but success on the third try. All right, so how to manage the file system that's in the flash or the configuration file. So for example, if you type show file system, here's everything that's inside, inside the flash. The operating system, for example, will be in there. This is for a switch, It tells you how big they are too, right? We're probably gonna, I don't know if you're gonna be able to use them. You can back up and restore. You store all of these text files like we did before. Use the log, and I usually don't even do this. Just copy and paste is the best way to do it. Okay. Now, you may back up and restore using TFTP server. We'll practice some of this in on next semester, how to back up your operating system and your configuration file to a TFTP server. First, we have to set up a TFTP server. Okay, so copy the startup config to a TFTP server. You're copying the configuration file to the TFTP server. So question number 4. If it is question number 5, I lost track. How do you back up the configuration file that's in the NVRAM to a TFTP server? Here's the command. And how do you copy the operating system or the configuration file to a USB drive? So you stick the USB drive on the back of the router. It should be formatted in FAT16, and you use the copy running USB flash 0 with a front slash, and that will allow you to do that. So it'll copy the running configuration file to a USB this way. Okay. Integrated routing services. This is having everything into one device and where you cannot change any of the configuration. For example, when you buy these Linksys wireless router, it has the routing in there, the switching and wireless connectivity all in one box. Cisco comes up with they have a lot of these Cisco integrated services router, such as these, that does everything for you. But, and they are less expensive than these corporate mid-size routers like the 2811 or the 1940, what is it, 1942 routers, uh, because they give everything is hardware. So you can't really make a lot of changes to them. Okay, for example, these wireless Linksys routers allow you to go from A, B, the mode, you can set it up into A, B, G, N, A, B, A, D, right? The SSID is the name of the network that's going to be broadcasted by the router. the wireless channel. You can divide the channels into 11 channels. So if you have, for example, um, interference with another device at home, you can change the channel from 1 to 11 and so on. So they'll be using different frequencies. All right. You can actually you can tell the wireless router to disable the SSID broadcasting. So if anybody's trying to break into your network and do denial of service, will not be able to. Make the most important thing is to you to set up a security, WEP or WPA. Just go to the router, enable that. They'll ask you for a key or a passphrase. You type that in, and next time you go in on your switch on your device, and you're trying to connect to that wireless router, they'll ask you for that key again. You type that in and you'll be good to go. You never have to do that again. Usually it's hashed on your computer and we'll always use that to send data out. You have to do that. Security is very, very important in a wireless LAN because anybody can then attack your router and bring it down anytime. But when it's encrypted, it'll be very difficult to do. All right? So make sure your wireless router is secured. So how do you access this integrated router that has the routing, switching, and all the access, the wireless access to it? Well, first of all, you hardwire your router, right? Connect it through any of the 4 Ethernet ports on the wireless router that you have. And I think you go to your web browser and you type 192.168.0.1. I think that's the default. And the default admin username is admin and the password is admin. And bingo, you're in. And once you are in, you can go in here and change all the defaults. Change the SSID, the name that's going to be broadcasted. Down here, you can disable the SSID. But if you disable the broadcasting, you got to remember the name that you typed so you can put it on your computer, because otherwise you won't be able to get in too. And of course, set up the security encryption. You go under security, wireless security right here. Enable either WPA or WEP, and type in your key. By the way, this GUI interface most likely will be different than if you use a different router. Let's say you use Netgear, but the information is pretty much the same. You just got to find them. All right. And then once you're done, if you have an old device, then you have to set up your NIC. But most today's PC, they already can determine and they can already configure they've already been configured for wireless. You may have to add a new software like a Linksys software on your laptop to allow the communication to be very quickly. But most PCs don't even need that. They will immediately connect and can recognize and communicate to your router. All right, that's it. So I hope this was an exciting semester. Next semester is going to be even better. Next semester will take us into routing and switching. Almost every lecture that we do next term will be um, hands-on. So we'll be able to, talk about it, and we'll be getting on Packet Tracer to show you how things work. And then all we have to do to learn it when we come to class is to do a lot of hands-on. So it'll be less of just listening to me, and you'll be a little bit more involved, and I would like you to get involved as well. All right. Anyway, so until next term, we'll see each other in Net W205. I want you to, if you have missed any of these lectures, please go back and review them before you take your final. It's preferable that you go through all 8 chapters and then just listen to what we're doing. So in case you missed anything, don't forget to read your book, and good luck on your finals. And if you have any questions, please do not hesitate to ask. All right. Maybe I'll see you next term. If not, God bless.